Hey guys, welcome back to new video. And in today's we're looking into the types of vector, and starting with the very basic, the equal vector, the first type. uh, we'll understanding this with an example. And here we have taken 5 centimeter vector A and 5 centimeter vector B, and we've got the same units and the same direction. This sort of vector is called equal vector. Like the magnitude, the direction, and the unit are the same. Like over here, if you see, we have got 5 centimeter. uh, we have got the vector A and B. The magnitude is 5 centimeter, 5 centimeter, but the unit is different. So due to change in only one property, this is not a equal vector. We need to remind this. Like for suppose there would be uh, 10 centimeter vector A and 15 centimeters vector B, so that they would be not the equal vectors. Moving for the second type, we have got we are taking the first examples, the same example. What we do is like magnitude is the same and the direction is only opposite. The units are same, the magnitude is same, the direction is only opposite. This is kind called the negative of a vector. Like we just make an opposite vector of that. Like we only change the direction. uh, in the case of negative vector, the direction always changes, while the magnitude may change or not. This is the case. Moving forward for the third, the third type of the vector, and we have got uh, the parallel vector, right? Here we have got parallel vector. Parallel vector. What does that mean? Uh, whatever vector do you consider, like this one I've taken, like I'm just taking this vector A, and this is for suppose 10 centimeter, and this is kind of vector B. This is 1 centimeter. Now what do you think? Like, are they equal vectors? Not, because the magnitude is not the same. Are they negative vectors? No, because the direction is not opposite. Only see a similarity that they have got a similar direction, and that is how this vector is. Like we have got the same direction, but the magnitude can be different. Here it is as well. Uh, if magnitude can be different, the unit can also be different. So we have got the same direction, and we have got parallel lines, the parallel vectors, and they do not meet at any point, and this is how it forms. I do hope that you've got it, and they're quite simple as well. Now this parallel vector is kind of a type of equal vector. Like equal vector type, they both are linked. The parallel vector and equal vector are kind of linked. Like we can say that equal vector is one of the form of the parallel vector. Like this vector, the equal vector, is also a parallel vector because they are not meeting at any point. uh, Moving for the fourth one, we have got the anti-parallel vector. Anti-parallel vector. Now for this I would give just a statement that would make you guys clear. Like when negative vectors form parallel vectors, they are termed as the anti-parallel vectors. Like this is A, and this is 6, for suppose 6 centimeter, and over here we have got this 7 centimeter. Now the magnitude is different and the direction is opposite, and they are also parallel. But the direction is different, so they become anti-parallel. They are form of negative vectors, but the change is like in negative vectors we have got particular or the same magnitude, while here it can be varying from vector to vector. That is not the same. So moving forward for the fifth type, that is collinear vector. Collinear vector. Now what does it mean? For this vector, but this is kind of a line I do draw over here. Drawing this is this one. This is kind of sorry, I want to draw a straight line. Let's see I'm able to draw it or not. This is yes, let me give it a try. So, okay, so this is kind of a straight line, and what if I do make vectors on this line, like this is, and this is third one, this is big difference, like again this one, like I do make random vectors on this, like this is A and this is A and this is B and this is C and the D remaining one. So what do you think, like they have all some sort of link? What is the link? They are all lying on a similar line. So these sort of vectors are called as collinear vectors. They are lying on a similar line, and this is how it works. Like magnitude can be different, but they'll on a single line, and their direction would be probably the similar as well. Now moving for the sixth type, we've got the coplanar vector. Six, we've got coplanar vector. Now for this one, sorry, for this one, let us consider this is a plane. This is my this is my copies page, and this is a page, and we do consider this as a plane. This is a plane surface, this is a plane. Now what do I see is I do see like there are vectors from here is a vector over here. Sorry, this is out of the plane, so this would be not counted under it. For suppose I've got this one or little one over here and the one over here. Now what do we see, like they are all lying on similar plane, like they are all lying on a similar plane. This is the type of a you know this is also a coplanar vector. This is they are lying on the same plane. This is how it works, and these are types of coplanar vector. And I do hope that you got it, like kind of a simple thing. uh, Now let's move forward for the other type, and that would be probably the position vector. Now you got other type, number 7, position vector. Now what does it mean? uh, like position vector, we have looked into a kind of vector that is formed, like we have got x-axis and y-axis, and on this we did look at this x and y-axis, and for suppose uh, this is a point P, this is a point, okay, P point, and I do make a vector over here from the origin, and this is termed as a position vector. The position vector is the vector that determines the position of any point on a plane, or you can say on the axis, and this is formed as the resolution of a vector. Like by this we can find we found the position vector by looking for x-axis and y-axis, and this is quite helpful in the resolution as well. Now let's move forward. We've got the last type, that is what is this number 7, 8, okay, it's 8, and we've got the last type, that is the free vector. Now what does that mean? Like okay, so if we do see that I would like to include a point, like vector, the position vector is always from the origin line. Do remember that, because that is showing the link between the the x and y axis. So we have got an origin. Again, we've got in free vector, we got y and x axis, and we've got some differences, and we're looking into this. So origin, and now if I do consider some vectors from here, this is a vector, and over here I do make this parallel path, and This is the free vector, like the vector that can parallelly shift, like this vector can do a parallel shift, and this vector has not any connection with the origin, like this is just a parallel movement. It cannot change its position, just it can change its position in the parallel direction, like it cannot go front and back, it can just go right and left. This is a thing, and this is called a free vector. Like we can just shift it wherever we do want, and we will be using it in the upcoming videos, and maybe we have used it in before. And in upcoming videos, when we are you know taking out the resultant vector formulas, we'll looking into the free vector as well. So I do hope that you learned something. If you did, do like the video, and meet you guys in the next video. Till that, goodbye.